Human-computer interaction, or HCI, is the study of how people interact with computers and to what extent computers are developed for successful interaction with human beings. This interactive system diagram illustrates the basic relationship between users and computers. Users provide input, which the system processes and returns as output. HCI is a multidisciplinary field that draws from various academic disciplines. It combines knowledge from computer science, psychology, design, sociology, and many other fields. The field of HCI has evolved significantly over time. This timeline shows the development of computer interfaces from early systems like Xerox Alto to modern operating systems, illustrating how user interfaces have become increasingly intuitive and user-friendly. A key aspect of HCI is the user-centered design process. As shown in this diagram from IDEO, the process involves cycles of inspiration, ideation, and implementation, always keeping human needs at the center. The primary goals of HCI are to make technology accessible, create user-friendly interfaces, tailor systems to human needs, and ultimately improve how humans and computers interact. At its core, human-computer interaction aims to bridge the gap between humans and technology, creating computing systems that are not just functional, but also intuitive and enjoyable to use. The core principles of human-computer interaction guide how we design effective interfaces. At the heart of HCI are four fundamental principles that shape how interfaces are designed. The first core principle is user-centered design, or UCD. This approach emphasizes involving users throughout the entire design process. UCD follows a cyclical process of requirements gathering, conceptual design, prototype testing, and refinement based on user feedback. The second principle focuses on mental models, which are the internal representations users have about how a system works. Mental models shape how users interact with interfaces. When a system's design matches users' mental models, it becomes more intuitive and easier to use. The third principle covers affordances and constraints. Affordances suggest what actions are possible, while constraints limit interactions to prevent errors. For example, this calculator interface uses logical constraints to prevent division by zero, guiding users toward valid operations. The fourth fundamental principle is usability, which ensures systems are easy to learn, efficient to use, and error-free. Usability evaluation encompasses multiple factors, including user control, accessibility, consistency, and alignment with users' mental models. These four core principles of HCI work together to create interfaces that are intuitive, efficient, and satisfying to use. User experience, or UX, is a critical component of human-computer interaction that goes well beyond basic usability. UX focuses on the overall experience of using a product or system, including 5 key aspects: aesthetics, emotional impact, user satisfaction, engagement, and accessibility. The UX design process follows a circular flow with 5 important stages: empathize with users, define problems, ideate solutions, prototype designs, and test with real users. Don Norman's framework identifies 3 levels of emotional design: visceral, which concerns immediate reactions; behavioral, which relates to usability; and reflective, which involves deeper meaning and connection. Good UX design considers user expectations and behaviors, while bad UX creates confusion and frustration. Even small design decisions can significantly impact the overall user experience. Accessibility is a crucial aspect of UX design. An accessible website includes features like correct color contrast ratios, descriptive links, and compatibility with screen readers to ensure usability for people with diverse abilities. UX professionals focus on multiple aspects, including user research, information architecture, interaction design, usability evaluation, accessibility standards, and visual design principles. Good UX design offers numerous benefits: increased user satisfaction, higher conversion rates, reduced support costs, stronger brand loyalty, and a significant competitive advantage in the marketplace. To summarize, UX extends beyond basic usability to create meaningful experiences. Well-designed systems should be both functional and enjoyable, with accessibility ensuring inclusive experiences for all users. Artificial intelligence and machine learning are introducing revolutionary changes to human-computer interaction. These advances emerge from the intersection of multiple disciplines. Machine learning, effective computing, and multimodal interaction all contribute to modern HCI. AI-driven interfaces can adapt to user preferences, significantly enhancing usability and engagement. Personalized recommendation systems analyze user behavior and preferences to suggest relevant content. These systems match streaming content to individual user preferences and refine recommendations through query policies. Generative and adaptive interfaces dynamically evolve based on how users interact with them. UI elements, layouts, and visuals can transform to better serve individual needs and workflows. Predictive text is a common example of AI-powered HCI that we use daily. The system analyzes typing patterns and context to suggest the most likely next words, significantly speeding up text entry. AI systems can create personalized user journeys by recognizing whether someone is a new or returning user and adapting the experience accordingly. Authentication workflows, navigation paths, and content recommendations all adjust based on user history. AI-powered personalization in HCI offers numerous benefits. It enhances efficiency by reducing user effort, increases engagement through relevant content, improves accessibility by adapting to different abilities, and continuously learns from interactions to improve over time. In summary, AI is fundamentally changing how we interact with computers. Personalization creates more intuitive and engaging experiences, where interfaces adapt to individual users rather than forcing users to adapt to interfaces. These technologies will continue to evolve, becoming increasingly sophisticated and central to HCI design. In recent years, several emerging technologies have been transforming how humans interact with computers. Voice recognition technology is changing how we interact with our devices. Smart speakers and virtual assistants now understand natural language, enabling conversational interfaces. These systems allow hands-free operation and can perform increasingly complex tasks through voice commands alone. The technology continues to become more context-aware and personalized. Gesture recognition technology allows computers to interpret human movements and translate them into commands. Using advanced cameras and sensors, systems can track precise body movements. This technology enables more intuitive interactions and has applications in gaming, healthcare, and accessibility tools. Increasingly, gesture interfaces combine with other modalities for richer interaction experiences. Immersive technologies are redefining how we perceive and interact with digital information. Virtual reality creates fully immersive digital environments that transport users to new worlds. VR is increasingly used in training simulations, education, and entertainment. It enables experiences that would be impossible, dangerous, or impractical in the physical world. Augmented reality, in contrast, overlays digital information on the physical world. It enhances our perception of reality rather than replacing it entirely. AR is finding practical applications in navigation, retail experiences, and medical procedures. It creates a seamless blend between digital and physical worlds. These emerging technologies are already finding practical applications in our daily lives. In-vehicle systems now combine voice assistance with augmented reality navigation for safer driving. Other applications include touchless interfaces for healthcare settings, interactive educational experiences, and enhanced retail shopping with mixed reality. These technologies are also transforming remote collaboration with more immersive presence. These emerging trends in voice, gesture, and immersive technologies are creating more natural, intuitive, and immersive ways for humans to interact with computers. They're gradually blurring the boundaries between our digital and physical worlds. Ethical considerations in human-computer interaction are becoming increasingly important as technology becomes more integrated into our lives. An ethical framework for HCI encompasses 5 key areas: human-centeredness, fairness, transparency and explainability, accountability, and privacy and security. HCI professionals must address several key ethical issues. These include privacy concerns related to data collection and storage. Bias in AI systems is another critical concern. AI can perpetuate and amplify existing biases in our society if not carefully designed and monitored. We must also consider the broader societal impact of our technology, including effects on employment, social relationships, and mental health. HCI professionals need a structured approach to ethical decision making. This process helps ensure that all ethical considerations are systematically addressed during design and development. Ultimately, HCI professionals must strive to create technology that is fair, equitable, and beneficial to all users. This includes designing for accessibility, ensuring that technology is usable by people with diverse abilities and backgrounds. By thoughtfully considering these ethical dimensions, we can create human-computer interactions that empower users while respecting their rights and dignity. Let's explore some examples of effective human-computer interaction in our everyday lives. From search engines to ride-sharing apps, effective HCI design improves how we interact with technology daily. Google's search engine is a prime example of effective HCI. Its clean, minimalist interface allows users to find information quickly and intuitively. Google predicts user intent with autocomplete, personalizes results based on user history, and provides instant feedback, all key principles of effective human-computer interaction. Spotify exemplifies personalization in HCI design. Its interface leverages user data to create tailored music recommendations. Spotify's algorithm considers factors like songs you repeat, listening time, tempo preferences, and similar users' habits to enhance your music experience. Uber's app demonstrates how good HCI design can transform transportation. Users can request rides with minimal steps while tracking their drivers in real time. The app provides clear ride options, price estimates, and driver information, creating a seamless experience from booking to payment. These applications succeed by following key user interface design principles that make interactions intuitive and satisfying. Effective HCI also means adapting to platform-specific design guidelines. iOS and Android interfaces differ in visual style, typography, and interaction patterns. These examples succeed because they prioritize user needs, provide clear feedback, minimize cognitive load, and adapt to individual users, demonstrating how effective HCI enhances our daily interactions with technology. The field of human-computer interaction is evolving toward a new paradigm, human-centered artificial intelligence. This represents a fundamental shift from traditional HCI approaches to ones that emphasize the symbiotic relationship between humans and AI systems. Human-centered AI applies the core principles of human-centered design, being people-centered, solving the right problems, understanding systems, and creating simple, effective solutions. Human-centered AI focuses on optimizing how humans use AI, making AI accessible to diverse populations, enabling meaningful human evaluation of AI systems, and ensuring alignment with human values. One practical implementation is hybrid AI systems where humans and AI collaborate. These systems enable joint decision-making and allow for human correction of AI errors, ensuring more ethical and effective outcomes. Next-generation interfaces, including brain-computer interfaces, augmented reality, and natural language systems, will transform how we interact with AI, creating more intuitive and seamless experiences. The ultimate vision for human-centered AI is technology that is not only intelligent, but also empathetic, ethical, and aligned with human flourishing. This involves enhancing human capabilities, ensuring ethical AI implementation, and creating truly inclusive technology.